So next concept that is called measurement technique for high impulse currents. Okay, and also Rogowski coil. Okay, Rogowski coil and this principle of operation of measurement of impulse current. So in this way, we have to in this. Okay, so we have to concentrating on now here Rogowski coil. Okay, for measurement of high impulse current. Okay, measurement of high impulse current. Otherwise, Rogowski coil. By using this Rogowski coil, you have to measure very high value of impulse current. Okay, so in this measurement of high impulse current or very high value of current, that is called Rogowski coil. This is called scientist name. So one of the scientists is designed this experiment. That's why his name is given like this: measurement of high value of current. So okay, so impulse currents, measurement of high impulse currents. So here, principle of this magnetic potentiometers, that is called Rogowski coil. So here, when a coil is wound surrounding a current carrying conductor, the voltage induced in the coil. Okay, this principle is nothing but when a coil is wound surrounding a current carrying conductor. Okay, when a coil is wound surrounding a current carrying conductor, the voltage induced in the coil like this. Okay, the coil is surrounded by the current flowing through the conductor. Coil is surrounded. So then some amount of EMF induced, that is called VRT. Okay, this is the principle of operation. Understood? When a coil is surrounding the current carrying conductor, this the voltage is induced in the coil. This is the principle of operation of the Rogowski coil. Okay, this coil is surrounded by the current flowing through the conductor. Because of this, some amount of EMF induced in the coil, that is called this VAFT. This voltage VAFT, voltage induced in the coil VAFT, that is called VAFT, is depending on mutual inductance, that is called M into dift by dt. VAFT is equal to M into dift by dt, where M is called mutual inductance between the conductor and the coil. Okay, IFT is called current flowing through the conductor. M is called mutual inductance between the the conductor and the coil, and IFT is called current flowing through the conductor. And then construction, coming to the construction, the coil is wound on a non-magnetic former of toroidal shape. Okay, the coil is wound on a non-magnetic former of toroidal shape and is placed surrounding the current flowing through the conductor, and is placed surrounding the current flowing through the current carrying conductor or current. Understood? So here, to reduce the leakage reactance, the coil is wound crosswise, and to get enough signal induced, the number of turns on the coil chosen to be large. The number of turns on the coil chosen to be large to get enough signal induced in this voltage. Okay, so this is called coaxial cable. This is called RC circuit. This RC circuit is called integrated circuit. This is called integrated RC integrated circuit. This is called coaxial cable. So this called coaxial cable, this used to avoid the reflections in the voltage. It's used to avoid the reflections in the input voltage. So VRT is called this voltage induced in this coil is proportional to the current flow into the conductor. Okay, so to get enough signal induced, the number of turns on the coil is chosen to be large. Then, so enough signal is generated. Okay, that is connected to our RC integrated circuit through a coaxial cable. This coaxial cable is used to avoid the reflections. Okay, so that is called this design like this. R1 is equal to Z0. So the R1 resistance of the circuit is R1 is equal to Z0. So by arranging the like this, so the reflections can be avoided. Okay, so this called Z0 is called coaxial cable surge impedance Z0, and RC is called integrating circuit. And then so VMAP is called our input voltage, that is called our direct current voltage. So this voltage VMAP our output voltage, measured voltage. Okay, so here the Rogowski coil with integrating circuit as shown like this. So output voltage VMAP is equal to, so because of this integration RC circuit, that is called integrating circuit. So 1 by RC into integration 0 to T into VAFT, that is called 1 by RC into integration 0 to T M into DIFT dt, DIFT by dt. So VAFT is nothing but M into DIFT by dt. Na VAFT is equal to M into DIFT dt. That is so substitute here VAFT in place of VAFT, that is called 1 by RC into integration 0 to T into M into DIFT by dt. So then when RC is called time constant of the integrating circuit, time constant for RC circuit is nothing but RC. Okay, this is called RC is called time constant of the integrated circuit, and the equation of this circuit is called Vm of t is equal to m by c into r into I of t. So like this, we will get the equation. Our measure value, so like this, proportional to the current I of t. Okay, output is proportional to the current value I of t. So in this way, we have to measure very high value of current. So voltage signal is proportional to the current measure. Okay, if the current measure is very high, then voltage is also very high. So according to that, we have to design the scale, and we can even measure very high value of impulse current. Okay, so for higher frequency above 100 megahertz, the response is affected by capacitance per unit length along the coil. Okay, for higher frequencies above 100 megahertz, the response is affected by capacitance per unit length along the cable, along the coil, and also skin effect is also. Okay, skin effect is also affecting measurement, and electromagnetic interference. Okay, so these are the different types of effects. For high frequency above 100 megahertz, the response is affected by these factors: capacitance per unit length along the coil, and also skin effect and electromagnetic interference. Okay, for ultra high frequency measurement, okay, miniature probes with response time are nanoseconds and made up with few tons of copper strips are used. Okay, so this is for this is the working principle of Rogowski curve for measurement of high impulse current, high direct current, or high impulse current. Rogowski curve for measurement of high impulse current.